Hello friends, in this video we are going to discuss about the topic of cyclotron. So basically the cyclotron is the machine. Okay, it is nothing but machine. What is the purpose of this machine is it is used to accelerate the positive charged ions. Okay, why it is used? It is used to accelerate positively charged particles. Okay, which are the positively charged particles? So we can see the proton is the positive charged particles, then we have deuteron, then we have alpha particles. Examples you can give as to be helium. Okay, to accelerate the positively charged particle, that is proton, deuteron and alpha particle, this is very important, to high energies. We are getting the positively charged particles which is accelerated to high energy. So in this video we shall discuss how the cyclotron helps the positive charged particles to attain high energy. So here this cyclotron was invented by Lawrence and Livingston, which was discovered in the year of 1934. So what was the purpose of investigating it? To investigate the nuclear structure. Okay, it was invented to investigate the nuclear structure. This is also very important. So here what happens is, in the cyclotron, what happens? The charged particles move in both electric as well as magnetic field. This is very interesting concept in the cyclotron. So here the charged particles will move in both electric as well as magnetic field, which are perpendicular to each other. So these magnetic field and electric field are perpendicular to each other. Here what is the purpose of electric field and what is the purpose of magnetic field? Here the purpose of electric field is to accelerate the charged particles. This will be asked in MCQ, that what is the purpose of electric field. So purpose of electric field is to accelerate the charged particles, and the purpose of the magnetic field is to make the charged particles move in the circular orbit. Okay, what is responsible for the motion of charged particles in circular orbit? We can say magnetic field is responsible and electric field will help to accelerate the charged particles. Okay, and this is to move in the circular orbit. Now let us understand what is the construction of cyclotron. So here you can see the construction. So basically, make this connection, this is construction. Okay, so in this construction of cyclotron consists of two hollow semicircular discs. These are the semicircular discs, which is known as D, since it is in the shape of alphabet D. Okay, so this D, they are the semicircular disc, metal disc. Okay, and this whole disc is placed in the vacuum chamber. Okay, so this is placed in the vacuum chamber. So at the midpoint of these D's, we have the positive charged particles. Okay, which is located at the midpoint of the gap between the D's. Okay, hope you understood this. And these D's, okay, these D's are insulated from each other. They are not connected to each other. They are insulated from each other and enclosed inside a vacuum chamber. Okay, so this D's is connected to a oscillator. So this is high frequency oscillator, that is the external power supply. So as a result of what? Since the oscillator is connected, as a result of this, varying electric field is produced in the gap between these D's. Okay, so what is the purpose of this powerful high oscillator? It is to produce the varying electric field between the gap of these D's. Okay, so inside this D, so inside the D's, you need to note that the electric field is 0 inside the D. So inside the D's, the electric field is 0, or we can say it is having the potential constant. So this whole apparatus is placed under the strong electromagnets. Okay, it is placed under the strong electromagnets. These are the strong electromagnets, which is again perpendicular to the plane of this D's. Okay, hope you have understood the construction. We have two semicircular D's which is insulated from each other and enclosed in the vacuum chamber, and this whole apparatus is under the strong magnetic field, okay, which is perpendicular to the plane of the D's. Now let us understand what is the theory behind this. So here what happens is, suppose the charged particle is over here, okay, and the power is given to the, that means it is connected to the external power supply. So as it is connected to the external power supply, at the initial what happens, this is at negative potential and D1 is at positive potential. Since it is connected to the alternate power supply, D2 is negative potential and D1 is positive potential. As we know that the proton is positively charged particles, due to electrostatic force of attraction, what happens is this proton will move towards whom? It will move towards the negatively charged D. So it will move towards negatively charged D. This is due to the electric field. Okay, it is accelerating. Now due to the magnetic field, it will move in a circular orbit. As it covers the circular orbit, as a result, with the help of oscillator, the potential is changed now. So this is now maintained at negative potential and this is maintained at positive potential. Since the potential is changed now, that is positive, and this is negative and this is positive, so positive negative attract, so it will move to the D's, that is D1. This process will continue, okay, it will be fluctuating between positive and negative potential. Now this will change. So when it changes due to electric and magnetic field, it will accelerate and move in the circular orbit. So this process will continue, and as a result of this, what happens, this proton will get a large amount of energy. Now with the help of this deflection plate, we have deflection plate at this point, or we can consider the deflector plate at this point. So from the deflector plate, the proton will come out of the oscillator and it will hit the target. Okay, this is the target, or it will hit the nucleus where the nuclear reaction will takes place. Hope you have understood. So here what is happening, we can say that when the D1 becomes the negative potential, okay, and D2 becomes positive, the positive ions is accelerated in the gap, this gap towards D1 and entered into the D2 with a greater speed. So inside this D2, what happens, the speed remains constant since the electric field is 0 inside. So inside it is 0, right? So it will remain constant, or potential is constant. But because of the perpendicular magnetic field, the ions moves along the semicircular orbit. Semicircular, this is semicircular, right? So it will move along the semicircular orbit of greater radius. Okay, this is a greater radius. But as what happens, but the time takes place to cover this semicircle remains the same. Okay, hope you have understood. Now let us understand what is the theory behind this. See, what I can say, suppose R is a radius. Okay, you consider that R is the radius of this outermost orbit. R is the radius. Okay, from this point to this, R is the radius of this outermost orbit. And the velocity while moving in this outermost orbit is V max. So from that we can say that force due to the magnetic field, since inside the D's the electric field is 0, now here who will act? Only magnetic field will act. So therefore due to magnetic force, we have that magnetic force is given by Q into V cross B, right? This is Lorentz force equation. So this is moving with a maximum velocity in the outer orbit. Since it is moving in a circular orbit, the centripetal force is provided, so that we can say V max square divided by R. This is the equation for centripetal force. So from here 1V get cancelled. If you want to find V, then keep this here, that is V max. R will move to this side, we will get BQR divided by M, right? So this is the expression for maximum velocity we get. And now since we know that the kinetic energy of the ion when it was moving, what is the kinetic energy? Kinetic energy is given by K is equals to half mv max square, right? So now from this equation what you can do is, see, we have two equations, that is V max is equals to BQR divided by M, and we have kinetic energy to be half mv max square. You can substitute the value of velocity from this equation. So therefore the kinetic energy equation will become half m. What is V max? It is BQR divided by M. This is, since it is square, so therefore it is square. Now open this bracket, this is half, 1m from here and 1m from here will get cancelled since it is m square, right? So therefore 1m here and this is square, 1m here will get cancelled, will get b square q square r square divided by, since 1m got cancelled, will get only single m. So this is the kinetic energy equation. Let us consider this as equation 2. Now you need to know the condition. Okay, what is the condition for acceleration of ions in between the gap, that the time interval, time taken by the ions to travel that semicircular disk, right? It was traveling like this, so it was moving like this. So this time was equal to half of the time interval. So therefore we can say that we can write here the condition of acceleration of the ion in the gap between the D's is that the time taken by the ion to travel in the semicircular path is equal to the half of the time period. Okay, what we can say, it is equal to half of the time period. So therefore we can say that pi m by bq is equals to t by 2. Hope you have understood this equation. So from where do we get this equation? So in order to get this pi m by bq, you need to go to the previous equation. See, as I said, it described the semicircular path. So therefore, the velocity equation is given by distance by time, right? If you want to find the time, so that time, that is t, will be equal to, what is the distance? That is the semicircle. If it is full, then it will be what? 2 pi r. If it is half of this, then it is half. So 2 will get cancelled, will get pi r. So therefore this d is what? Pi r, and the velocity is v. So this is the time taken to travel in that semicircular orbit is equal to half of the time period. So this is half of the time period. Now this t is what? Pi r by v. So from this equation, what you can extract for r is what? R, we can consider it to be small r for small orbit. If it is r, then we'll get Vm divided by bq, right? This is the value for r from this equation. So this is Vm divided by bq will get you r. If you substitute in this equation, we will get pi into what is r, that is Vm divided by bq, and we have here v. So this v and this v get cancelled, we'll get pi m by bq. Hope you have understood this. So therefore we can say that the time taken to travel in a circular orbit is equal to the half of the period of the oscillation of the applied high frequency oscillator. So from here we can take t is equals to, you just multiply here, 2 pi m divided by bq. This is the time period. Okay. Now we know that the time period is inversely proportional to the frequency. So therefore we can say nu is equals to, nu is here frequency, that is frequency of the oscillator. So frequency of oscillator is equals to 1 by t, which is equal to, what is 1 by t? This is reciprocal of this. So numerator will go to the denominator, denominator will come to the numerator. So this is your frequency of oscillation. Hope you have understood this. So this is known as cyclotron frequency. What it is called as? It is called as cyclotron frequency. Okay, so the final kinetic energy of the ion, how can you say define the final kinetic energy now? So it will be equal to, I'll try to solve it over here. As we have this equation, V is equals to BQ by 2 pi m, we can take a nu pi is equals to BQ by 2m, or we can also write it as nu pi 2m is equals to BQ. Okay, now the previously we have found the kinetic equation, that is K is equals to B square Q square R square divided by 2m, right? Now what is BQ? If you, here we have B square Q square. So if we square this, what we will get here? Nu square pi square 4m square. So substitute this value of B square Q square here, you will get nu square pi square 4m square. This are done. Then we have R square divided by 2m. So 2 1s are 2 2s are 1 and 1m get cancelled. We will get, this is 2, right? So 2 nu square pi square m R square. So this is the final kinetic equation. This is very important. It can be asked for numericals. Then this formula you need to use. So this is the theory behind the cyclotron. So here what happens, the positively charged ions are ejected. Okay, they are ejected out of the Ds, but they are not ejected in the continuous form. It is ejected in the pulsed stream. Okay, how it is ejected? It is ejected in the form of pulse streams. So these accelerated particles which we obtain from the cyclotron, it is used to bombard the nuclei. Okay, where it is used to bombard the nuclei in order to study the nuclear reactions, and also which is used to produce the radioactive substances, and this radioactive substances which is used in the medical diagnosis and treatment. So these are the uses of cyclotron. Hope you have understood what is the construction, working and the uses of cyclotron. So out from the cyclotron, one question is for sure in GPSTR or HSTR. So in HSTR they can ask you what is the final kinetic energy, or they will ask you what are the uses of the cyclotron, or they can ask whether the positively charged ions or the negatively charged ions are used in the cyclotron. So your answer should be the positively charged ions. Hope you have understood. If you have liked the videos, please don't forget to like the video and subscribe to my channel, and kindly share with all the aspirants if you know who are preparing for HSTR. I am giving you complete this syllabus, okay, and detailed explanation. So thank you.